Hey guys, today we're going to be talking about solving systems, and this is day 2, okay? So this should kind of already be familiar with you guys. Remember, we learned 3 different ways: substitution, elimination, and graphing. Now, from now on, I'm going to pretty much focus on solving systems by graphing because I think most of you are going to find that easier. Now, if you prefer one of the other 2 ways, elimination or substitution, then please feel free to use them. Now, first thing we're going to talk about are the 3 different types of answers, okay, or solutions you can get when you have systems, okay? Now, the first type that we can have is when you have a situation where there's different slopes, okay, and different y-intercepts. You end up with a situation that looks like this. Notice it's basically 2 lines that intersect, all right? And what that means is there's actually one solution. Where do you find that one solution? Right where the 2 lines intersect, okay? This is the most common answer that you're going to have, but there are 2 special cases. So let's say there's a situation where you have the same slope but different y-intercepts. Well, hopefully we remember that anytime we have lines that have the same slope, we know that these lines are parallel, which means that these lines never touch. So if they never touch, that means there is no solutions. They have no answer. And finally, the last one is very special because not only do they have the same slope, but they have the same y-intercept. Now, if 2 equations have the same slope and the same y-intercept, then they end up becoming the same line. So the lines are the same. And if the lines are the same, that means they intersect at every single point along the line. So there are infinitely many solutions. So we're going to solve these by graphing. All right. So if you notice, our first 2 problems are our first 2 equations already have y by themselves. They're already in slope-intercept form. So we're just going to identify what the slope is and what the y-intercept is so that we can actually graph this. So for number 1, the first equation, y equals x minus 3, I notice that the slope is 1. And I'm going to write that like a fraction, 1 over 1, because my directions are going to be to go up 1 and to the right 1. Now the y-intercept here is negative 3. Alright, let's look at the second one. Second equation, y equals negative x plus 3. Well, that negative x can actually be a negative 1x. So the slope is negative 1, make it look like a fraction, over 1. Well, what would be the directions for that one? Because the 1 on top is negative, I actually have to go down 1. The bottom one is positive, so I still go to the right one. The y-intercept in this situation is actually a positive 3. So let's go ahead and graph these lines. We'll start with the first one. And remember, you must begin with b. So my first point is going to be at negative 3, because that's what I said the y-intercept is. And according to that slope that I wrote, I said to go up 1, right 1. So I'm going to go up 1, right 1. Notice I'm going to do this a few times so that way I can draw a pretty good line. Arrows at the ends. Alright, now the second one. Alright, that y-intercept, right, because I begin with b, that's our starting point, is at positive 3. And the slope for that one was to go down 1, right 1. So down 1, right 1. What you should already notice is that these 2 lines, down 1, right 1, intersect. Okay, I do see that these 2 lines intersect, and I see that they intercept right at this point. And just to add another little special note, what's special about this point is that it's also known as the x-intercept because it's on the x-axis. So the answer is, looks like it crosses at 3. So how do you write an x-intercept? the number, comma, 0, so 3, comma, 0 is the solution for our first situation. Now number 2, same thing. Let's identify our slope and y-intercept. So the slope for number 2 is 2 over 1, because I have to write it like a fraction. What would be the directions? Up 2, right 1. The y-intercept is a negative 1. Okay, now the second equation. The slope for the second equation is negative 1 over 2. So notice it's already a fraction. So let's write our directions. Negative 1 is on top, so that means I have to go down 1. 2 is positive on the bottom, so that means I go to the right 2. The y-intercept is also negative 1. This should already tell us something if we know that the y-intercepts are the same. But let's go ahead and graph it so you can actually visually see what I'm talking about. So let's graph the first line. And we begin with b, which is at negative 1. And according to that slope, we said that we're going to go up 2 and to the right 1. Up 2 and to the right 1. Up 2, right 1. Notice I can't go any further, so I'm just going to go ahead and draw my line as straight as possible. Arrows at the end. Alright, now let's do the second equation. Also, y-intercept at negative 1. But this slope tells me to go down 1 and to the right 2. Down 1 to the right 2. Which line do you think is steeper? The red line or the blue line? Hopefully y'all agree that the red line is definitely steeper because the slope is bigger. Now, what you should notice here is that these two lines intersect at the y-intercept because they have it the same. It's the exact same, so we actually already knew that before we even graphed it. So the answer or the solution, okay, is one specific answer, which is the y-intercept, which is 0, negative 1. Remember, our solutions are always supposed to be written as a point. Alright, well, we're just going to work out these problems by just simply solving for y or putting it in slope-intercept form. Then in class, I'm actually going to go over how to do this in your calculator. So, let me just kind of go over our steps to solve for y or put things in slope-intercept form. So I'm going to sing that song that you guys love that it's going to help us with those steps. So please do not make fun of me. First you box your variable, cancel what's beside it, divide by what's inside the box, reduce, and you solved it. Alright, so let's go ahead and work this out. First I'm going to box my variable, which is y. I have a line down the equal sign. I'm going to cancel a negative x by adding x. What I do to one side, I know I do to the other. Okay, so I cancel what's beside my box. I bring down what's in the box, so y equals x plus 0. I can't combine them, so I just bring them both down, x plus 0. But technically, do I have to write x or the plus 0 part? No, so really the answer is just y equals x. Alright, the second equation, same concept. First I box my variable, which is a positive 2y. I cancel the positive 4x by subtracting 4x to both sides. We cancel what's beside our box. Let me bring down the 2y equals. Remember, negative 4x and a negative 12, you cannot combine them. They're not alike. So I'm going to just bring them both down. They're both coming to the party. And finally now, I divide by the number inside the box, which is the number 2. So I'm going to divide everything by 2. And we get y equals, well, negative 4 divided by positive 2 is negative 2, bring down the x. Negative 12 divided by 2 is negative 6. So when we get to class, we're going to actually finish this problem to figure out what our solution is. So let me go ahead and jump on over to number 4. First thing that I need to do is box my variable, which is a negative 3y. I cancel a positive 3x by subtracting 3x. What I do to one side, I do to the other. Alright, let's see what happens. That cancels out. I bring down the negative 3y equals, remember, negative 3 minus 3x, we can't combine, so I bring them both down. And now, all I have to do is divide everything by the number inside the box, which is negative 3. So, my answer is, those cancel out, we get positive 1y equals positive 1x plus 1, because negative 3 divided by negative 3 is positive 1. So there's our first answer, okay? So I'm going to erase this so that I can actually work out the second one. So give me a second. Hopefully you guys got that all down. All right. First I box my variable, which is a negative y. I get rid of that or cancel the negative x by adding x. Okay, so we end up with y equals, negative 1y equals x minus 5. Well, my last step then is to divide everything by negative 1, because that's the number inside the box. So negative 1 divided by negative 1 is positive 1y equals. I'm going to write the number 1 next to that x so that I remember that's what's supposed to be there. And 1 divided by negative 1 is just simply negative 1x. And negative 5 divided by negative 1 becomes a positive 5. So there are two equations, and like I said, when we get back to class, we'll figure out what the actual solution is with our calculator. Alright, same exact thing. Remember, we're putting these equations in slope-intercept form, which you guys know is y equals mx plus b. Okay, so first I box my variable, cancel what's beside it by making it a minus x. Okay, we cancel what's beside our box, and I bring down the negative 1y equals negative x plus 1. We can't combine them. I divide everything by a negative 1. And our final answer is that y equals positive 1x minus 1. Now let's look at the second equation. Same exact concept. First I box my variable, cancel what's beside it. This time I cancel it by subtracting x because it was positive at first. Alright, so I cancel what's beside my box. I bring down the y. Notice the y is already by itself, so this is a really simple one. All I have to do now is bring down the negative x plus 3, and there's my answer. We have two answers here, and we're going to figure out what the solution is when we get to class. Do you notice anything special about them? Do they have anything in common? No, the only thing I notice is that their slopes are opposites, right? They have opposite slopes. Alright, number 6, exact same concept. First I box my variable, negative 6y. How do we cancel a positive 2x? I'm hoping you said by subtracting 2x. Alright, we cancel what's beside our box. I bring down the negative 6y equals, and then I have to bring down the negative 2x and the negative 12. Alright, divide everything by the number inside the box, which is negative 6. And our answer is that y equals, we get positive 1/3 x plus 2. Almost done. We got to do it one more time to the second equation. First, I box my variable. How do we cancel a positive x? By subtracting x. Okay, so we end up with 3y equals negative x plus 18. Sorry, I don't have very much space. Let me try and rewrite this. y equals negative x plus 18. The last thing I need to do is just simply divide everything by 3. So those cancel out and we get that y equals, well, negative 1x divided by 3 is negative 1/3 x. And 18 divided by 3 is positive 6. There's our two equations. Do you notice anything about those? Anything the same? Anything really different? I just noticed that, again, these have opposite slopes. These are not perpendicular lines, though, because remember, to be perpendicular, they have to be opposite reciprocal slopes. We'll figure out the actual solutions when we get to class. Same thing again, guys, okay? So 2 problems, 2 equations. This is a system, so let's solve for y. Box my variable. Subtract 2x to both sides. Let's see. We cancel what's beside our box. I'm going to bring down the negative 3y equals negative 2x plus 12. Last thing I need to do, divide everything by the number inside the box, which is negative 3. And I end up with y equals positive 2/3, because negative divided by negative is positive. So 2/3 x. 12 divided by negative 3 is negative 4. Alright, now let's work out the second one. First, I box my variable. We cancel a negative 2x by adding 2x. Okay, so we cancel what's beside our box. We get 3y equals 2x plus 24. Remember, those don't combine, so you have to bring them both down. My next step is to divide everything by the number inside the box, and we get y equals 2/3 x plus 8. Do you notice anything about these? What is that? They have the what? Same slope. Why? Yes, you are correct. They sure do. Look at that. Same slope, same slope. And what do we know about lines that have the same slope? I think you're correct again. They are parallel. And if they're parallel, do we actually already know the solution? Yeah, if you go back to the first slide, remember we said parallel lines mean that there is no solution. Alright, number 8. Let's go ahead and solve these. First, I box my variable. I cancel a positive 2x by subtracting 2x. Okay, negative 3y, just brought that down, equals negative 2x plus 12. Divide everything by the number inside the box, and we end up with y equals positive 2/3 x minus 4. There's the first one. Now let's work out the second one. First, I box my variable. Notice here I'm going to add 2x to both sides. I end up with canceling what's beside my box. 3y equals 2x minus 12. I know my last step is to divide everything by the number inside the box, which is 3. 3 divided by 3 gives me 1y equals 2/3 you can't reduce, so you keep it, 2/3 x. But negative 12 divided by 3 is negative 4. So there are my two equations. Do you notice anything special about them? Oh, you do. They have the same slope. And anything else? Do they have anything else in common? And the same y-intercept. Well, if they have everything the same, then this simply means that they're just one line. They're the same exact line. And remember, if the line is the same, because they become one, then there are many, infinitely many solutions. Alright, this next slide is I'm just writing the steps to solve the systems in your calculator. So obviously, after you have both equations in slope-intercept form, this is what you're going to be doing in your calculator. First, you type both equations in y equals. 2, you hit graph to see what they look like. Remember, there's 3 options. They either intersect, which means there's one solution. They're parallel, which means there's no solution. Or they're one line. They're the same line, so there's many solutions. If you can't see the graphs in your calculator, then remember we worked on this last class, zooming out, okay, which was go to zoom, hit number 3, and then hit enter twice. And then once you do that and you can see it, then you go to second trace, you hit enter 3 times, and the solution will be on the bottom of your calculator screen. Make sure that you take the time and you pause and write all these steps. Alright, so I guess we'll finish finding the solutions when we get back to class. See you guys later.